Hello students, let us study about sulfuric acid, which is an important oxo acid of sulfur. So sulfuric acid is H2SO4. First of all, let's see the manufacture. So it is manufactured by contact process. That process is known as contact process and it involves 4 steps. 4 important steps are there. First one is S plus O2 gives SO2. Second step is SO2 plus O2 gives SO3 in presence of V2O5. Then third one is SO3 plus H2SO4 gives H2S2O7, that is oleum. Fourth step is dilution of H2S2O7, that is H2S2O7 plus H2O gives H2SO4. So these are the 4 important steps involved in contact process. And the second step is actually the key step. So this is the key step in contact process. So consider this second step, SO2 plus O2 gives, it's a reversible reaction, SO3 is formed in presence of V2O5. So this is the reaction. So in this case, we can see this is an exothermic reaction. This is an exothermic reaction. So delta H will be negative. And regarding the volume 2 plus 1, that is 3 changes to 2. So volume is actually decreasing. Volume decreases in the forward reaction. So volume decreases in the forward reaction. So according to Le Chatelier's principle, in order to maximize the yield or in order to increase the rate of reaction, we have to apply certain conditions according to this, that is low temperature and high pressure. So low temperature and high pressure has to be applied. These two conditions have to be applied in order to increase the rate of reaction in the second step. So since it is a key step, we have to apply certain conditions to maximize the yield of sulfuric acid. So what are the favorable conditions to maximize the yield of sulfuric acid? That is an important question. Here we have to check the second equation or the second step, which is a key step, so that we have to apply certain conditions here, that is low temperature and high pressure. So low temperature means 720 Kelvin and high pressure 2 bar pressure. So these two conditions are very important conditions. These conditions has to be applied in order to maximize the yield of sulfuric acid. This is very important. Then let's see the properties. First of all, sulfuric acid is a strong acid. So it is a strong acid. So it ionizes in solution. Let's write the ionization. So ionization of sulfuric acid in water. So ionization, that is H2SO4 plus H2O gives H3O plus. So H plus will be existing in the form of H3O plus HSO4 minus. This is the first step. In the second step, HSO4 minus plus H2SO4, HSO4 minus plus H2O gives H3O plus SO4 2 minus. So these are the two steps in the ionization of sulfuric acid. Here the Ka value, that is the dissociation constant Ka1, since it is the first step, Ka1 is greater than 10. That means it is very large. So larger Ka value in the first step. In the second step, we can see there is Ka2, which may be 1.2 into 10 raised to minus 2, which is smaller. So Ka1 is very greater than Ka2. So why Ka1 is very greater than Ka2? That is another question. Here we can see then the first step, the ionization will be very easy. So it is very easy to release H plus in the first step. So the release of H plus, or the dissociation of H2SO4 to H plus and HSO4 minus, that is very easy. Or large dissociation will be there in the case of first step, and the Ka value, Ka1, will be very large. In the second step, the second proton, so it is difficult to release the second proton in the second step. So in the second step, second proton is released. That is very difficult. So from HSO4 there is a release of H plus. So that is very difficult. So the dissociation constant is less. So if dissociation constant is more, dissociation constant is more, stronger will be the acid, or the strength of the acid will be more. So if dissociation constant is more, stronger will be the acid. So Ka1 value is more than Ka2 value. So in the first step, the ionization is very easy and the dissociation will be more. So large dissociation is there in the first step. In the second step, the second proton is released. That is very difficult in the second step. So second proton, the release of second proton is difficult in the second step. So the dissociation constant value is less. So in the first step it is easy. And one more thing, that is, if dissociation constant is more, or Ka value is more, stronger the acid. So if Ka value, or the dissociation constant is more, stronger will be the acid. So that is the point. Then another point is about its dehydrating nature. So H2SO4 is a good dehydrating agent. That means it absorbs water molecule. For example, if it is sugar, C12H22O11, so it's a dehydrating agent. So if H2SO4, since H2SO4 is acting as a dehydrating agent, it absorbs water molecule from here. So all the water molecules will be absorbed by this H2SO4 and we will get carbon. That means charring of sugar will take place. So all the water molecules will be released and charring of sugar takes place and carbon will be the product. So C plus H2O. So you need to balance this equation. Then another point is it is a strong oxidizing agent. It's a strong oxidizing agent. Here we can use three equations to explain the oxidation property. That is, it's an oxidizing agent. So H2SO4 is a strong oxidizing agent. It oxidizes. So if we are using copper plus H2SO4, we will get CuSO4 and sulfur dioxide and water. So this will be the common product in all the cases. So sulfur dioxide and water. So this is a reaction. So copper is actually oxidized to copper sulfate. So another equation is S plus H2SO4. Here it will be sulfur dioxide and water itself. Then regarding carbon, Carbon is oxidized to carbon dioxide. Again, sulfur dioxide and H2O are other products. So sulfur dioxide and H2O are here in all the cases, and it is oxidizing. So it's a strong oxidizing agent. Copper oxidized to copper sulfate, sulfur oxidized to sulfur dioxide, carbon oxidized to carbon dioxide. Here in all these cases, H2SO4 is acting as a strong oxidizing agent. So regarding its uses, you have to refer NCERT textbook. So this is about sulfuric acid.